Okay, class, today we're in lesson 3.1, representing proportional relationships. Lesson 3.1, representing proportional relationships. Essential question. How can you use tables, graphs, and equations to represent proportional situations? Representing proportional relationships with equations. The ratio of the distance in miles to the distance in leagues is constant. This relationship is said to be proportional. A proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. A proportional relationship can be described by an equation of the form y is equal to k times x, where k is a number called the constant of proportionality. Sometimes it is useful to use another form of the equation, k is equal to y over x. In other words, they solved this equation for k. They got k by itself.
Proportional relationships are really, really great because what we can do is we can see that one thing is growing at a constant rate, and that's actually called the constant of proportionality. And we can actually find that constant, and once we have that, knowing that rate, we can actually determine about how other things that are proportional are changing. Okay, that's a lot of words and use of the word proportional. Let's take a look at an example where we can actually make it make sense. A walking tour of Washington, D.C. costs $20 per person. Let's show that the relationship between the number of people in a tour group and the total cost is a proportional relationship. So we want to now verify something's a proportional relationship. And then let's see if we can actually write an equation for that relationship. To test to see if something is a proportional relationship, what we have to do is we have to actually collect some data, and we have to look at the ratios of those pairs of points. And if the ratios are constant, then we actually see that we have a proportionality. Okay, so let's take a look at a little chart here. So let's say number of people in the tour group, and let's figure out the cost, knowing that it's $20 per person. So, just for fun, I'll just write some numbers in here. Let's suppose that we have one person in a group. Let's say we have a tour group of 5. Let's say we have a tour group of 10. Let's say we have a tour group of 20. Okay, now, if we charge $20 per person, then if it's only one person, we know this is going to cost $20. If there are 5 people, well, 5 times 20, we know is $100. If we have 10 people, we know 10 times 20 is $200. And if we have 20 people, we know that 20 times 20 is $400. Now, to actually see if we have a proportionality, what we want to do is look at the ratio. And we want to look at the ratio of total cost to number of people, which means we want to create a fraction, if you will, and simplify it as much as possible. Total cost to the number of people, and then see. So for this first collection of, this first pair of data, we have a cost of, just for fun, I'm going to use a different pen, we're going to have a cost of 20, and we have one person. And so what does that reduce to? That reduces to 20. In the second ordered pair, we see we have a cost of 100, and we see the number of people is 5, so we're looking at the ratio 100 to 5, or 100 divided by 5. And if we simplify that, we actually see 20 again. Interesting. Do you see a pattern? I do. Let's try this one. If I take the total cost of 200 and divide that by the number of people, 10, then I'm looking at the ratio of 200 to 10, and that's easy to simplify. I can just see that's 20. And now I'm really feeling it. I'm feeling it. Do you feel it? I'm feeling a constant proportional. How about this one? 400 divided by 20. And again, the ratio 400 to 20 simplifies to just 20. Well, 20, 20, 20, 20. You don't need 20/20 vision to see all the 20s. So, What that means is, since these ratios are all the same, they're all equal, that implies that this relationship, in fact, is a proportional relationship. Now, if it's a proportional relationship, that means we can actually write an equation for it, because proportional relationships all have the same type of equation. They all look like this. Y equals K times X, where the X is the unknown that's representing the first variable, if you will, and the Y is representing the output, which in this case is total cost. So X is representing number of people, the Y is representing total cost. This is what we put in, and knowing that, this is what comes out. So these guys are variables. The K is not a variable. The K is a constant. The K is a number, and in fact, in this case, it's the constant of proportionality. So it's that constant ratio we kept finding. So in this case, the K is actually 20. So if we want to write the equation for this particular proportion, we would write Y equals 20 times X. And remember, if we don't write anything in between the 20 and the X, that automatically means it's multiplication. So it's saying Y equals 20 times X. And that, in fact, is the equation for this relationship. And we were able to find that by realizing that this relationship really is a proportional relationship. Proportional relationships are all around us in everyday life, like actually taking tours in Washington, D.C., or any city for that matter, or even in growth and in science and even in economics. So looking for proportional relationships is really something to value. And if you have one, it's easy to write an equation for it, because it's always going to be Y equals some constant of proportionality times X. Have fun finding proportional relationships in your life, and I'll see you soon.
Okay, after viewing the video, it should be pretty easy to understand example 1. Megan earns $12 an hour at her part-time job. Show that the relationship between the amount she earned and the number of hours she worked is a proportional relationship. Then write an equation for the relationship. Step 1. Make a table relating amount earned to number of hours. For every hour Megan works, she earns $12. So, for 8 hours of work, she earns 8 times 12, which is equal to $96. So, number of hours, 1, 2, 4, and 8. Amount earned for 1 hour is 12. 1 times 12 is 12. For 2 hours is 2 times 12, 24, and so forth. 4 is 48. 8 is 96. Step 2. For each number of hours, write the relationship of the amount earned and the number of hours as a ratio in simplest forms. So in other words, you're going to write amount earned is on top and number of hours is on the bottom. In other words, Y is on top, X is on the bottom. So on the table, X would be your number of hours, Y would be the amount earned. So down here, when they say make a ratio, the ratio is going to be Y over X. Y over X. So in each case, you end up with 12 over 1. Here, 12 over 1 comes out. Here you get 24 over 2, which reduces to 12 over 1. Here you get 48 over 4, which reduces to 12 over 1. And then 96 over 8, it reduces to 12 over 1. All right, now to reduce, you're saying 2 goes into 2 once. 2 goes into 24 12 times. So that's why that's 12 over 1. Here, 4 goes into 4 once. 4 goes into 48 12 times. 8 goes into 8 once. And then 8 goes into 96 12 times. All right, now if you're having trouble with your multiplication and division facts, that means you got to go even smaller. Notice here 48 divided by 4. Both numbers are even. So if you can't tell that 4 can go into 48, then what you may have to do is stick with 2, and then 2 goes into 4 twice. 2 goes into 48, 24. And now you're back here. Now 2 goes into 2 once, and 2 goes into 24, 12. Same thing with this one. Start with 2 and then work your way down. Okay, now our last step, step 3, is going to be write an equation. Let X represent the number of hours. We did that earlier. Let Y represent the amount earned. We did that earlier. Use the ratios as the constant of proportionality in the equation Y is equal to K times X. Once again, use the ratio as a constant of proportionality in the equation Y is equal to K times X. The equation is Y is equal to 12 over 1 times X, or Y is equal to 12 times X. So in other words, Y, that's your Y there, K is now 12 over 1, and X stays as X. Once again, Y stays the same, equal sign comes down, K is now 12. 12 divided by 1 is 12. So our final equation then is Y is equal to K times X, where we know that K is really Y over X.